My name is Jack Coor, and I'm the Research Director at Payload. Welcome to our webinar on the future of ground systems. It's a very interesting topic. I'm super stoked about it today. I think it's a topic that is very important, but often under-discussed. So today's webinar, we're going to try to make this very interactive. We'll just have a conversation, the three of us. I'll introduce the panelists in a second, but there is a Q&A field box at the bottom of the Zoom where you guys can just pepper in, whoever's listening can just pepper in questions along the way, and we will get to it either at the end or if we can, we'll try to weave it in throughout the middle of the webinar. So with that, we have very exciting and awesome panelists today. We have Mandy from Terran Orbital, and I'll have them go around and introduce themselves as well. But we have Mandy from Terran Orbital, we have Dave from L3Harris, and Andrew from AI Solutions. So with that, Andrew, I'll toss it over to you if you want to give a brief intro on yourself and maybe your organization's relationship or how your organization plays in the ground systems, space ground systems ecosystem.
Sure. Yeah, absolutely. Thanks for the introduction. Glad to be here. I'm Andrew Warner. I'm the Chief Product Development Officer at AI Solutions. The company is almost 30 years old, started back in 1996, and I've been there for just a little over a dozen years. The company name, the AI, is for artificial intelligence. It's some artificial intelligence we did right at the beginning of the company's lifetime at NASA Goddard in the mid-90s. And today we do a lot of work for NASA, Space Force, Missile Defense Agency, international space agencies, commercial customers, all sorts of folks. Anyone doing some space related, we're probably there somewhere. I specifically lead the development and the support of our astrodynamics software products, the main one being Free Flyer. It's history almost as long as the company. And specifically as it relates to ground systems, the reason we're here today is our software has been used in dozens of ground systems, used on hundreds of missions, doing the flight dynamics piece specifically. So everything associated with the orbit. Where's my spacecraft been? Where is it now? Where is it going to be? How does it need to maneuver? Those sorts of things. And so we do the flight dynamics ground system aspect for the space station, James Webb Space Telescope, Landsat, the Artemis missions, and a bunch more. But that's probably enough for me. Thank you.
Awesome. Thank you, Andrew. And Dave, we can toss it to you for an intro.
All right. So Dr. Dave Vidito, I'm a physicist by training, but nowadays I pretend I'm a systems engineer. I am the enterprise ground lead for the space systems sector for L3Harris. And so as part of that, I cut across all of the teams that are building ground in one way or another. I joined Harris about 25 years ago, give or take. Various programs. The first big one, just to give you a sense for the kinds of things we do, was the GOES-R ground station. So this was a $1 billion ground station that we built about 15 years ago now. Shows you how old I am. And that was to do all of the mission management, command and control, contact management, data processing for geostationary weather satellites. So when you see a hurricane hit Florida and you see the imagery on the news, the big swirling hurricane, those are images that my team originally helped create for that system. So Harris is a system provider. So space vehicles, both the payload, the vehicles themselves, and the ground system. So we have a tendency to look at ground from an end-to-end perspective, beginning to end, all the way through processing, tasking all the way through processing. Nowadays, I'm helping out with our missile warning, missile defense team, Space Defense Agency. We have some tracking satellite systems that we're building. So yeah, I'm happy to join in the conversation. So definitely bigger picture for us. We bring in tools from other companies as they make sense. We take advantage of free and open source software, and we build a lot of things ourselves. So we're a big integrator of capabilities across the spectrum.
Thanks, Dave. And Mandy?
Hey, Jack, thanks for having us here today. I'm excited to chat about ground systems and all the things related to mission. I'm the VP of Engineering for Spacecraft Design for Terran Orbital, and Terran Orbital is really a 85% vertically integrated responsive space industry leader. So from concept all the way through launch to deorbit, we have that capability really in-house. So, and one thing that I really enjoy thinking about throughout my career is the concept of mission capability and data as decision-making currency. So with Terran Orbital, we have the ability to rapidly create new capability. We have the rich history of the CubeSat, which brought satellite capability to a more broad audience and amplified that ability to do rapid open source development. And so that's what really drew me to Terran Orbital and the capability of the talent here. We've really scaled from CubeSat all the way to really complex constellations very quickly to enable that broader audience and broader community of space access. We do have 5 Terran Orbital operated ground stations, so that allows us to really own our supply chain, own our destiny, own our data, as well as partnering with others for kind of ground as a service capability. So pretty excited to be here, pretty excited to talk about the future of ground capability.
Great. Yeah. Thank you. Thank you to the three of you. So as you just mentioned, the webinar is going to be on the future of ground systems and ground capabilities. But I think what will be helpful before we get into that to set the stage here is just a very brief, maybe 30 seconds. Maybe Angel, I'll toss this to you, but a 30-second overview of what does the term ground systems mean? How does it play in the ecosystem of communicating with space assets?
Sure. I mean, the quickest way to say it is the ground system's everything that's on the Earth, all the capability on the Earth that keeps the spacecraft operational and performing its mission. Some processing does take place on board the spacecraft as we talk about the future of ground systems. I'm sure that'll come up later in this call. But there's more computing resources available on the ground. There's operators available on the ground, humans on the ground. And so the ground system handles data transfer to and from the spacecraft, planning what the spacecraft needs to do, communicating that with the spacecraft. And that could be things like turning on a heater, performing a maneuver to avoid a collision, or explain where to point a sensor to collect some data. I realize that that's kind of my background of where I'm coming from. Dave or Mandy, if you guys have different perspectives or if I've said something wildly inaccurate, please jump in.
Ground capability really as how we get the data that's in space to the people who need to use that information, right? So data is currency. How do we communicate with the awesome things that we're able to do in space and the capability that's up there? So it's really the transmit, receive, the processing, all of that really cool functionality.
We've had a number of debates. What is ground? Because it kind of depends a little bit who you talk to. As an example, we have ground systems where they are more antennas looking up. So those are ground systems. But I think for the purposes of this conversation, it's more satellites that tend to be Earth looking. And we're building the ground stations that do all of the tasking and management and command and control. And for us, the data processing also. So all of that going into it. And of course, nowadays, as the number of systems continues to grow, rapidly grow, it moves away from, can I do the management, planning, command and control and processing of an individual satellite or a small collection of satellites, but can I do that for a constellation? Can I do that for a fleet? That's becoming more and more important as we move forward.
Great. So that is a good segue into the topic at hand, and that is what the future of this ecosystem looks like. You just mentioned moving from individual satellites to constellations and proliferated constellations. So the implication there that there's more data, more satellites up there, more data flowing through. Maybe Mandy, I'll swing this one to you. What are some other? Can you just talk about what are some other trends you're seeing that your team is looking at to prepare for the next 5 years, and to be able to better serve operators?
Yeah, I'd say one of the biggest bottlenecks is really that anomaly resolution time to really things are going to go wrong when you're in space. Space is a dynamic environment and ecosystem. And so helping operators be able to triage and understand when things are in an anomalous state, or predicting when we are going to be in an anomalous state, helps with that cognitive burden of resolving that anomaly faster. And so that's an area where, we have capability in-house today to be able to do some of that. But really it's about using the human mind more intentionally around the harder problems, and allowing technology, AI, ML, deep training of algorithms, and known past historical insights in space, depending on the orbital regime, the environments you're in, the type of missions you're supporting, the ground coverage. We're able to create, the ability for the machines to help operators work smarter, not harder. There was mention, I don't want to steal Dave's thunder, but there's mention of, just this limited human capacity and ability to respond, right? We're not going to have tens, 20s, hundreds times more operators supporting missions or experiments in the future. We need to have the machines help the operators and leverage that AI, ML, deep learning, algorithm type capability, depending on the time of day, the type of mission, the availability of the spacecraft. I think that's an area that is going to continue to amplify as we look into the future.
Yeah, if I could add on to that a little bit, the term that I'm hearing from a lot of our customers, and I should say that most of our customers are more government oriented. We tend not to do a lot with commercial systems, other than we ingest commercial data sources into our systems, but so government. And the term that I'm hearing a lot is cognitive agents. And I think what they're getting toward, and I think where we're heading, is our government customers at least want to have smaller, focused, AI, ML or related technologies that can help automate, help make it easier for the limited, the operators we have are trying to manage all of these satellites. And so I think it'll be a highly distributed system of cognitive agents. And I wouldn't be at all surprised if the government insists in setting it up so it's an ecosystem, so that many different contractors or many different government agencies can develop cognitive agents and insert them at different places. So it could be in assisting with fleet management. It could be in product quality control of the products that are coming out. It could be in checking for anomalies in satellite telemetry. It could be in any one of a number of areas. But I'm kind of seeing over the next 10 years, I think you're going to see that more and more. These smaller, independent, distributed cognitive agents.
And by cognitive agent, you're referring to some sort of AI, ML tool?
Typically, that's what they're referring to.
Yeah. And would you see that being one? So the implication from what I'm hearing is that maybe each customer would have their own independent AI tool rather than a more generalized one.
I suspect they'll want many different tools from many different providers. They want to avoid getting locked in. That's kind of a history of this business, right? You had a few big primes that would provide big systems, and more the government wants to get away from that. They want to take advantage of the breadth of capabilities across the industry, and so they're trying to set it up so that many companies can contribute. And I think you'll see that here with on the AI ML front. They're going to want multiple companies to be able to bring the best and brightest to solve whatever problems they have.
Yeah. Okay, great. So to summarize and contextualize what you guys are saying now, we're seeing in the next, well, we've seen the last 5 years, and we're going to continue to see the next 5, 10, 15 years, more proliferated constellations, more satellites, more data, exponential increase in data needed to be both downlinked and also processed on the ground. But the ground systems aren't going, the number of human resources to process that on the ground aren't increasing with that. So your teams are all looking for tools that can better process and more efficiently process it. And one of those tools can be some sort of AI, ML slash automation tool. And Andrew, how is your team at AI Solutions looking at this really difficult problem of just a increased demand and increased ask from your customers on processing much more data?
Yeah, I think it's a good question. There's obviously automation is a huge piece of it, being able to, I mean, lights out operations isn't a new term in the industry. That's not the future of ground systems, and in a lot of places that's where we're at already, and a lot of our systems are already doing that. But the idea of handling more than just nominal operations in that way, being able to handle anomalies, being able to handle things that happen that are a little bit unexpected without necessarily having to bring an operator into the loop. You can do that if you have one or two spacecraft, but as soon as you start getting above that, yeah, you're gonna, you've got to have the system be able to handle those things on its own. And AI is certainly a way. One of the other things that we've seen, just kind of taking a slightly different tact, is being able to have your capability scale, and the cloud obviously comes into this, being able to use resources that aren't just what what you have available on premises, but being able to go to the cloud and being able to scale up so that oh, this worked when we had our first launch, it worked after our first 5 launches, and it'll work when we have our 500th launch. So you're not limited to what your current physical hardware is. You've got to be smart and intentional, though, about your ground system architecture, how you do things so you can take advantage of that scale and use that smartly. I know that one of the things that we do for that is using containers so that you can spin up these new instances really quickly and be able to get more compute time, more processing, but in a way that's easy to spin up and spin back down, type of thing. I know there's the ground system architecture workshop every year, GSAW, and we've had a couple of people speak at that in the past, but even just earlier this year, we had someone speak about how we've been using containers for at least the flight dynamics piece of a ground system.
I'm a big fan of containers myself. I think that software has been really revolutionary in the way that even, I'll say, industrial DevOps starts to think of things, right? How do you containerize? How do you deploy capability faster? And for software, containerization, modularization is a huge part of that. Being able to deploy new capability while still maintaining 24/7 uptime, right? And just doing this failover, switchover capability. I think that we're going to see potentially in the future a lot more containerized capability on orbit. I think we use containers in spaces such as ground systems pretty regularly, and a lot more scalability can happen with clusters and Kubernetes and orchestration of that. But I think that we're definitely going to see more of those industrial DevOps principles and practices applied to physical hardware. Iteratively, how do we deploy satellites in batches faster? And we're seeing some of that with tranche-based launches. If we can't digitally uplink something or upload something, we're able now with better rideshare, faster, cheaper rideshare capability to launch in orbit faster, more often. So I think it's cool to see that continued play between cyber physical systems and the digital realm, and how those are going to allow us to have access to more modern, rapid capability in space than ever before.
Great. Can you quickly define what you mean by containers?
Do you want to go ahead, Andrew?
Yeah, Mandy or Andrew.
Why don't you take it, Mandy?
Yeah. No, containers are really kind of I hate to say containerized, but they're really like these modular systems in a software realm that serve as these mini operating systems where you can modularize functionality and provide the capability to do parallel compute. They're really cool to be able to spin up applications and technology very fast. Barrier of entry is pretty low, but it's coming from more of that on-prem infrastructure mentality we've had for the last few decades. It really allows you to operate, I'll say, cloud, on-prem, really that ecosystem agnostic environment where you can have multiple containers, multiple versions of things, and fail over without even having a blip of loss of information.
I like to describe containers as very lightweight miniature virtual machines that kind of encapsulate a bit of software. And the goal with cloud architectures is now to deploy many, many instances, not only of the same software as you scale up your needs, but many different kinds for the many different applications and functions you need. And so you'll hear things like microservice architecture. That's where you're orchestrating all of these little mini containers and getting them to work together to provide the functionality, scalable functionality that you need. So
Yeah, and Dave, most of your customers, if not all of your customers, are government slash DoD. And how are they looking at moving to the cloud? Have they already requested that? Are you already in the process of doing that? And also, there's a question in the chat. I think it's really relevant with this. How does cybersecurity play a role in ground stations, ground systems, and also moving to the cloud?
So every one of our customers is pushing to the cloud. I can't think of a single one that is not pushing to the cloud, and they're doing it for good reason. It helps them with reliability, resiliency. They want to be able to take advantage of the cost model. Moving to the cloud won't necessarily save you money, but what it does save you on is if you don't have to build an on-prem compute server to provide your ground station with compute capabilities, you don't have to budget for that. So when you're building an on-prem capability, you have to budget every 7-8 years a big bill as you buy all new servers to recap all of that. So with cloud, you don't have to do that. It's a much more of a flat go from a budgetary perspective. So they're all moving that way to take advantage of that. It means rethinking the architecture, right? So they are going to have to think about how do you move toward more of that microservice architecture I was talking about. Cybersecurity is tricky. I don't know that there's going to be, I'm curious to see what the other panelists say. I don't know if there's any one solution. A lot of our customers are moving to C2S, so it's kind of a classified version of Amazon cloud services. And there are others, as GovCloud, where you could do some, not classified, but it's more restricted, unclassified processing. But it's always tricky. How do you get the data in and out? And that really varies by customers. I don't know if I can really give a one-size-fits-all answer to the cybersecurity question. And I also wouldn't consider myself an expert in that particular area, to be perfectly honest. I usually bring in my cyber experts to help with that one.
I think there's a balance on the cybersecurity front, right? I think there are certain assumptions, certain tests that you can run and make sure your capabilities are as hardened as possible, and may even have to assume just everything is potentially penetratable. But space and cyber is a very interesting topic that many people are studying, and there are opportunities such as Hackasat that happen. I mean, that's not specific to ground capability, but it is specific to satellite type technology. I think that's a yearly thing that happens. I want to say, with sponsored customers that support that. But it's a great learning opportunity for people to take part in, to learn how space-based assets can become vulnerable and how to penetrate space-based assets, and then baking that into continual learning of how would adversaries think and what would people be doing with space-based data that might be a bit more usable for its not original intent. So there are ways to bake in, from starting secure and staying secure, making sure you're running those code analyses, making sure you don't have those vulnerabilities for ground capability. But there are certain mitigations and certain courses of actions that you have to take depending on if you're assuming your assets are in a certain state or your ground capabilities in a certain state. And being able to have that redundancy, resiliency, scalability really helps mitigate, if you are in a state where you think something might be compromised. So it's all about the con ops that you work in, trying to think like someone who might be leveraging capability for nefarious reasons, and just trying to make sure that your capability is protected with a balance of what makes the most sense for the hardness and accesses that you need to protect.
There's historically, and with ground system, they're on air gap networks for that reason, to be secure, to make sure that right, you're not letting some other actor tell the spacecraft to change its orientation, do something that might disable the mission, that sort of thing. But and it's why, Dave, you were saying like, oh, we're making them, all these customers are looking towards the cloud or making the move towards the cloud, when in other industries that that's happened already in the past. It's okay, we're fine. We want to do it in a sensible and a smart, kind of way that doesn't expose the missions to any sort of risk there.
So we have a dynamic where there's more data coming in, more data flowing through. And in many cases, are your team seeing any bottlenecks with data and downlinking?
Yes. Yeah.
So
Some of the systems that we design will collect more data than it is possible for us to downlink. So in those cases, we have to do onboard processing. Now, you always want to downlink selected examples of the raw data, because you're always wanting to QC what's going on board with onboard processing. So that's been a challenge. I think that's going to change as mesh networks, space-based mesh networks, come into play. In theory, right? If that pans out well, and if there's enough bandwidth, in theory, some of those bottlenecks might go away. I'm not convinced that that's entirely true, because it's a race, right? As the networks increase, so are the capabilities of the systems, and so it's always a race between the two, and there always seems to be a bottleneck somewhere. So it is a challenge.
Yeah, well, that's an interesting. We're even seeing from the astrodynamics side, potentially, if you're in a constellation, if the spacecraft within the constellation are talking to each other, if they do have that kind of networking, then then they can even do with each other, adjust spacing and those sorts of things to to say, oh, okay, we're getting a little too close or a little too far away. Let's do our maneuvers, and let's do those dynamically, potentially with just onboard processing, without even needing anyone on the ground to intervene. And then, of course, you can get into things like self-healing if one of those spacecraft goes down for one reason or another, and you need to adjust on the fly from that. I know, Mandy, that's the thing you guys have been looking at, right?
Yeah, you kind of hit a few topics I was going to hit too, and I think we're touching on Alex's question here in the chat a bit on like, what do we see as the future of how we deal with large batches of data and proliferation of data, right? From a Terran Orbital standpoint, right? It's no kidding, the journey from a CubeSat to constellation and the complexities of communications within that, right? And there's a lot of innovations at play and opportunities at play in the space, especially when you have compact hardware and our satellites across the space industry are really getting smaller, right? That doesn't leave much room for more compute, and we have to figure out how to optimize the compute and take that more from a ground capability to on orbit, so our satellites can make better decisions based on their current state, course of action, where they're at, and also dealing with that throughput, right? There's opportunities to do some metadata tagging, right? Prioritization of the type of data and the type of messages you get back to the ground to be able to operate on or act on. Doing some analytics on orbit, again, to help with the latency and timing, and not having to do those big hops from space to ground, which do have latency just from a time physics standpoint. Being able to prioritize process on orbit is definitely going to be something I think the space industry continues to modernize and optimize over time, including pushing the compute to the edge.
One thing I do like to point out, though, whenever we have these conversations is, while we're seeing more and more onboard processing, I think there will always be a role for ground processing, because you can do significantly more on the ground because it's so much less expensive to implement the algorithms. One, processing hardware is cheaper. I don't have to worry about space, weight, and power of a satellite. So I can always do more on the ground. And so it's a balance, depending on the customer, depending on the mission and what they're trying to do. what do they need to do immediately on the edge and have immediate access to it? And what can they do on the ground so they can do additional value-added processing or extracting intelligence in some of the systems I build? So there's always going to be a balance between the two. It really depends on the mission and what they're trying to accomplish.
Yeah, definitely seems like a delicate act to juggle it. Andrew, I don't know if you can see the chat, but there's a question that I'll read off, and I'm not sure if this is a good one for you to answer, but I just want to alert you to it. So we have a question, and by the way, if anyone who's listening, if you have any questions, this is great. It's a great way to kind of direct our conversation. But the question is, how do orchestrated solutions survive the transition to flight software with no avenues to mitigate static analysis and safety verification issues introduced by fundamental runtime drawbacks like garbage collection?
I've been thinking about that. If you
And if someone can rephrase that question to make it make sense for everybody, including me as well.
I don't want to step on your thunder, but I've been thinking about that. It's a challenging question.
What I just saw it for the first time. So
Okay.
Dave, why don't you go ahead and try to rephrase while I buy myself some time to think about it too.
Okay.
And if you
Yeah,
can rephrase that too.
it is a complex question. And I'll just kind of pick it apart by looking at the first part. How do orchestrated solutions survive the transition to flight software? And then he gives some additional details. And I don't know that you're going to have in your flight software the same type of orchestrated solutions that you would have in a cloud system. In a cloud system, you're breaking the software up into many little pieces. This is the containers that we were talking about. And you worry about how do you orchestrate across all of those and how do you make it resilient. But you have some advantages on the ground in that if it breaks, I'm right there and I can work it and I can fix it and I can test it over and over and over. Whereas once you fly, it's a lot harder. And so I see orchestration with flight software a little different. The flight software has a defined functionality, and in the future, that defined functionality may become more flexible as cognitive agents kind of come into play, but it has a defined functionality. The orchestration then becomes how do you orchestrate all of these space vehicles from a fleet perspective so that together they perform the function that you need. So I do think you have to be very careful with flight software. It's very hard. If the flight software starts misbehaving, you're going to get in trouble quickly. So you want to keep it simple and do that orchestration across the space vehicle. So I'm not sure if that answered the question, but that was kind of my take on that.
No, I like that. I mean, it's definitely something to be careful about. There's various different trade-offs to make. From my perspective, we typically play at on the orbit, the astrodynamics, that facet of it. And so looking at kind of the second half of the question where you're talking about things like garbage collection, which, oh, geez, that's tying up my resources for my compute resources for a while. And how that could impact things from the astrodynamics perspective. The funny thing is we should not, in theory, ever be doing anything just in time from an orbit perspective. It's a nice thing that we don't have to worry about as much. And you should be planning that maneuver in advance. Even something like potential collision avoidance that's not a thing that you're not grabbing a joystick and waving around and getting it out of the way just in time. It's a thing that okay, maybe we don't have a lot of tracking data on the debris object, or maybe we just found out about it. But it is the kind of thing where we're making the plan. What's the optimal way to maneuver, or should we not maneuver to get out of its way? So it's actually one of the things from the orbit perspective. We normally don't have to be that kind of just in time reaction.
Yeah. Thanks. And Mandy, just jumping off the congestion in space conversation, just with increased congestion, increased need for space traffic management and collision avoidance, how is Terran Orbital looking at adapting ground systems to this changing environment?
Great question. Yeah, the concept of, I just think about like, we've got really cool, and I'm not saying Terran Orbital is doing this, just it's more of a thought of my own, but we've got really cool collision avoidance and street driving capability with human in the loop capability in our cars today, right? And that's come really far over the past even decade. Space is a much more dynamic ecosystem, and there's the ability to use smarter technology for real-time spectrum management. How do we minimize the amount of or really optimize the RF comms link capability, make sure we're using it when we need it and not when we don't need it, and prioritizing the RF contacts appropriately. But even just the navigation aspect and the traffic aspect that Andrew hit on a little bit earlier is really fascinating, and having those algorithms in place where you can do more intentional collision avoidance, estimating where your peer satellites may be that you know about, and then also doing some sensing of, the space deterministic ecosystem. I think we're going to see a lot more capability that maybe the collision avoidance from the land starts to provide opportunities for that more dynamic space ecosystem to do more of that navigation and collision avoidance technology share. So I do think that that's going to be a really cool technology insertion point and dynamic collaboration there. Again, it's not necessarily something I'd say we're doing right now, but we do have some really cool algorithm development and I'll say collision avoidance support happening.
Nice. Great, thank you for that. And I want to get back to one more question on cybersecurity, because we have, it's the vast majority of our questions from our audience. We have 3 pending questions. By the way, if anyone wants to put questions in the chat, please throw them in there. I know we did discuss cybersecurity, but I do think it is on the top of everyone's mind, and in many ways a mandate, particularly when you talk about national security, government applications. But Andrew, maybe I'll toss this one to you. If we can really just dig into how your team at AI Solutions is looking at cybersecurity, maybe what is the typical framework that you're using to establish procedures, policies for monitoring vulnerable analysis, and also just how you're looking at integrating third-party software and making sure everything is secure via that.
Sure. Yeah, no, it's a good question. Yeah, obviously getting into DevSecOps and how things are handled there. And I'll first give the same caveat that Dave did, that I'm not the cybersecurity expert. And so, oh God, please, forgive me if I say something tragically incorrect. But yeah, I mean, there's certain things we can do. I mean, one of the things that our company is doing is making sure that, we're falling in line with all the CMMC guidance. And as that's coming out, we're going to make sure that we're appraised against that and that we're doing things in the right way in terms of our maturity there. And it's something that, you've got it right. The sec part of DevSecOps is very, very important. You have to have that in mind at the start. That has to be, the first sprint of your product development has to include security from the ground up. It has to be something you're thinking about. It's even something, it's one of the things we talk about a lot when, with our containers, making sure that they're developed in secure ways so they can only be accessed in the one very specific way that we're intending them to be accessed as they get spun up and as they come back down. So we're not opening ports that we shouldn't be, or, exposing ourselves in some way that we shouldn't be. Even, if we're on GovCloud or any sort of different secure cloud, and, those environments, obviously there's a lot of onus on cybersecurity for them, but we need to make sure that what we're putting on there also isn't creating more vulnerabilities. In terms of, integrating third-party software, I mean, that's essentially, we would be that software. Some of our products, FreeFly or Meridian, some of the software products that we have for flight dynamics and ground systems would be those, for someone else, the third-party software that's being in, for someone like Dave at L3 or for Mandy at Terran, would be the third-party software that they're integrating then and putting in containers and those sorts of things. So we have to, have those, we have to do those tests. We have to, make sure that, we can show how we're being mature and secure. And then obviously there's the testing that they're doing on their end with the integration piece.
Right. Yeah. Yeah. I think it becomes particularly relevant when we talk about generative AI, LLMs, and there's a certain level of trust issues that maybe people have, but maybe it's kind of this we're all moving in that general direction. But we do know that LLMs and generative AI does have some hallucinations and especially in an industry where you really can't have failures. How do you guys look at integrating that, which would imply that it's past an AI or just basic AI or ML, machine learning software? How do you look at the new ways that AI is expanding?
Yeah, that was an interesting one because if you think about automation, right, you don't want any mistakes. And folks tend to be very conservative when it comes to their satellites because they don't want to break those very expensive satellites that they've launched, right? So if you're bringing in AI ML, and so like generative AI, I think you would use that more on to assist with, say, tasking and mission management, providing some assistance there so that you can do that at the fleet level. There has to be a cultural shift, I think, with a lot of the customers to be willing to, I don't know, it's going to take some time before they gain the confidence, put it that way, before they're willing to completely shift over. So I have a feeling for a long time, there's going to be, at best, shadow ops, a parallel, where you'll see what these systems can do in parallel with what operators are doing. And as they gain confidence, I think they'll switch over. But AI systems are a lot like people. We all make mistakes. It's a lot harder to give that trust over to an artificial system when it's not a person that you can talk to and do an after actions with, as an example. So it's just a fundamental shift in how we do business. But I don't know how we get away from it, considering how many systems that they're talking about flying. Thousands, tens of thousands of satellites in some constellations. So
I think we have to, yeah, I think we have to let the data do the talking, right? And over time, allow humans to realize there are certain things that we feel comfortable for the machine to do and operate on, and that we have past performance of shown capability that, machines, if we train them appropriately and we program them appropriately and give them the right swim lanes, right, they can operate with higher efficiency, higher ability, higher repeatability than a human can, and faster. And I think that those harder decisions need to be the ones that really need the operator or the human in the loop to make those decisions. It also depends on the mission you're supporting, right? And I do think that there should be more concerted effort to be able to train our systems. We certainly don't want, I was kind of joking off to the side, I shot Jack a note as I was mentioning, we don't want, people are concerned about us having, eventually robots take over, right? And we've trained up the robots and the assets to be, so smart that we can no longer control them. But our capabilities are only as smart as we are, right? And so being able to train them to operate appropriately and then have that data to enable decision makers to actually trust the capabilities that are being developed, right? We're seeing in space, right, faster capability being deployed, faster capability being commissioned, and commissioning is an area where we as Terran Orbital have not necessarily used AI ML, but have created algorithms and parallel opportunities to do quicker commissioning, right? We've had opportunities where less than 2 days we have capability up there communicating back to the ground, such as our Tantrum mission, right? That's an opportunity where we were able to, due to the tenacity of our operators and the algorithms and the capability that Terran Orbital has, within less than 2 days, start leveraging some of the capability and actually operating in unintentional environment where we were launched into VLEO versus LEO. Just having that capability where you can start to stand up those algorithms and ability to remove that bottleneck of human in the loop, and trust that the commissioning or the activities you're asking an asset to do is going to do what you asked it to do, helps enable that capability to be in somebody's hands faster. And we have to let the data do the talking to be able to enable that trust over time.
Yeah, that's one of the things that, yeah, I mean, we see that today. That's not even the future of ground systems. I mean, I think we're all seeing that, when a spacecraft will first launch, the operators, they want to really have their hands on it. They want to look at, again, just from our perspective, they'll want to have their hands in every maneuver that gets planned. And maybe the automation, will say, oh, here's the maneuver that we think should happen. And then the operator might review it. They might tweak it a bit. And then over time, the system can learn from those tweaks, and the operator realizes, oh, I'm doing less and less. I'm making fewer and fewer of those tweaks. The system's just kind of giving me a maneuver out of the box that I think, oh yeah, okay, that's right. That's what I like. Let's go with that. To the point where then the automation and all that can take over, and the operator can be. I think, Manny, we were talking the other day, and you referred to it as operator on the loop instead of in the loop, and I like that idea that the operator's there, they're kind of managing by exception then at that point, which kind of going back to one of the earlier topics, when you start talking about scalability, when you start talking about constellations and some of these different missions that are looking at that, you have to have that. You've got to be able to move from an operator looking and making all these different little decisions to just having that confidence in the system and saying, yeah, okay, what it's planning is what I would plan, and being okay with that.
So this move to manage by exception, that's really driven by the sheer volume of data that's coming through, and the volume of satellites that need to be operated.
Yeah, I would say so. I mean, I guess you could stand up, hundreds and hundreds of operators as you launch more and more spacecraft, but that also doesn't seem, like the probably the most cost efficient way to do that.
Yeah. And Dave, I'm curious from your perspective, because most of your customers are government customers.
Right.
And I'm curious how, just maybe high level, how the needs of a government customer might differ from a commercial customer, and particularly in this idea of having a human in the loop versus managing by exception. What do you see?
That's a broad topic. It depends. It's a lot to cover there. Well, let me step back a little bit, because I did think of a use case that could be for a government customer. It's a little different than what we've been talking about. Again, getting back to the original question about generative AI. If you step back before you're actually doing the tasking of the satellite, you could have a commander's view. And a commander could say, monitor all of the forces in this area of interest and identify hostile targets, right? So that's a very high level command that you could use generative AI. It ties into the mission management system for the constellation. It'd have to have knowledge of all of the different satellite assets, air assets, all the different capabilities of the sensors, and then figure out how do you optimally task all of those things in priority to give the commander what they've asked, while balancing it with all of the asks of all of the other commanders. So that would be a good use of a generative AI that a government customer might care about, because those commanders need the ability to give those larger, bigger picture orders, and generative AI could assist in that. Now that's going to generate a whole host of satellite vehicle mission plans and tasks. And so now you've got the problems that we've been talking about before. Well, how do I manage all of that? That's a whole nother thing. And of course, you have, once you start executing the mission, when is it appropriate to have operators in the loop? When is it appropriate to have things automated? It depends. Are we talking about a combat situation? Are we talking about surveillance? There's a lot of interesting questions here. So it's just a very broad topic that I find very interesting.
Mandy, do you have any thoughts on government needs versus commercial needs Dave just brought up a couple of interesting points, but in terms of that human in the loop, and when we look in the next 5, 10 years.
Yeah, Dave started to hit on some of the capabilities of what generative AI and could do for military-based customers. And one of the cool things about Terran Orbital is we have a very diverse set of people and missions and experiments that we serve. And so we do see that cross-pollination between industry and military capabilities. And what I've seen done before too is that machine learning training type algorithm development on activity-based intelligence, right? You can start to predict based on certain scenarios happening, certain courses of actions happening, how you want to use your space-based asset. And there are, common themes that you can pull across industry and commercial to be able to work smarter across, how do you train, how do you manage, how do you help an asset predict sooner what's happening and what types of options it has on the table there. I always think that flexibility, especially when you're dealing with cyber physical assets that maybe you can't deploy within a day or two. Maybe it might take days or weeks at the fastest, right, to get that launch window up there. But the ability to have the adaptable spacecraft is also an area where space-based asset would be an area that I've seen pulled across industry and military applications. An example that I can talk about is our Geostare application. Tomorrow is actually its 3-year anniversary of operating and being in space. So that's one area where we have 2 different types of telescopes on an asset with a partnership through a CRADA with Lawrence Livermore National Laboratory, 2 telescopes that support both Earth observation and space domain awareness. We talked a little bit about that. How do you navigate, manage the traffic management of other satellites? But that is an area where I do see, we've got investment in, and we're partnering with Lawrence Livermore on how do you advance that technology and have that dual capable, flexible space asset.
Awesome. And we have about 5 minutes left in the webinar. So the last question, I want to talk about the future. So right now we've been talking about this kind of 5-year down the line, 10-year down the line of what we see coming with proliferated constellations and increased data flowing through. But I want to go even further out. But before we do that, can we go around in a circle and we'll start with you, Andrew, and if you can just give your maybe email address where people can find you if they want to follow up for a question.
Sure, yeah, absolutely. It's andrew.werner at ai-solutions.com. Or you can probably find me on LinkedIn.
And how about you, Dave?
Same, dave.vidito at L3Harris.com. Last name's a little tricky, but you should be able to see it there in the Zoom chat there.
And Mandy?
Mandy.Rogers at terranorbital.com. And again, I'm pretty active on LinkedIn as well. So looking forward to a follow-up conversation.
Great, thanks. Okay, back to the question on the future of ground systems. Andrew, I know we had a conversation about different orbital regimes when we start talking about cislunar.
Yeah.
Just curious on your thoughts on how your company's looking at the future.
Yeah. No, absolutely. I mean, and yeah, my company is specifically being very focused on the orbit, side of the house, the flight dynamics piece of this. Yeah, some of these orbits that you're starting to see more and more of. I realize saying going to the moon, it's future, but it's also past. But the dynamics obviously are very different in with the third body, the 3-body system and everything that entails with that. The orbits are different. It's a different kind of thing. The intuition that you might build from working with LEO and GEO spacecraft and those things, not all of it applies. There's certainly some differences there. And even as we get beyond that, in the far future, going to the moon, or going to Mars, other kinds of missions, where you have to deal with the more complicated dynamics and seeing that. That's actually, we have a talk, I think someone's giving it at the AMOS conference later this summer, about using autonomous path planning to go from different kind of stable orbits in a cislunar regime from one stable orbit to the other, and using AI to help plan those maneuvers, to connect those trajectories. How might you maneuver to get from, an L1 orbit to an L2 orbit, something like that.
Great, thanks.
Sure.
Mandy, how about you on what you see the future of ground systems looking like, and how do you prepare for it?
Yeah, I think that we're going to have just some sort of leapfrog in technology, right? We can't keep operating the way we are today, where we've got limited compute power on edge, right? So I think that that's going to be an area that the next, hopefully, couple years, there's significant changes in how we do data processing, right? There's got to be opportunity out there for enhancements, and just people who maybe are totally outside of the space or compute domain to come up with innovative ideas on how we really push edge processing to the edge. And that is something that we are looking at internally, on how do we push that compute to space, push that data processing to the edge, and then improve inter-satellite communication as well. So more of that information sharing across satellites versus having to rely totally on the ground.
All right, thanks. And Dave, I'll leave you with the last word.
So, I don't know, for me, I'll call it ubiquitous comm, right? Where you have not just the mesh networks in space, but mesh networks in the ground, all of that. If that can ever get to the point where that really is mature and reliable, then a lot of the data bottlenecks that we've seen in the past go away. And when that happens, what can we do with our systems? It'll fundamentally change how we do command and control. It'll fundamentally change about how we think about how we use our systems. And so that'll be interesting. And as part of that, I'm hopeful that at some point it becomes easier for our tactical users to not just gain access to the data, but actually task systems. Whereas now they're kind of off to the side. It's really hard for them to make requests. But I can see, as communication continues to grow and become everywhere, and that communication bottleneck falls away, that we may have some systems up there that are more designed for use by our tactical users, and that'll be interesting. And who knows, maybe in a few years we might even fly compute nodes, systems in space specifically designed to do processing of data, right? Communicating data from the sensors, passing it over the mesh networks and compute nodes. There's some fundamental changes that could happen.
It's about pushing the data to where it's needed, right? And pushing that compute power to where it's actually needed and actionable.
Yes. Of
Absolutely.
course, those systems are also vulnerable, so you have to be careful. It's a real challenge.
That was a lot of the questions we had. This has been awesome. Andrew, Dave, Mandy, thank you for joining. I think this has been super interesting. Again, for everyone who's tuning in, I think they will all be happy to chat. Maybe LinkedIn is the best for people. We gave the emails earlier, but that might be easy if you have the names. And we will have this webinar is going to be posted on YouTube for people who might have missed the first couple minutes or whatnot. That'll be posted in a couple days. But thank you. I want to thank you all for tuning in. Appreciate it, everyone, and take care.